Hey, welcome! Today, we're going to tackle one of the most fundamental forces in the entire universe. We're going to connect a simple, everyday thing, like a piece of fruit falling, to the huge cosmic dance of the moon and the planets. So let's unravel this mystery together. So here's the puzzle that really gets you thinking. You see stuff fall to the ground all the time, right? An apple lets go of a branch, and boom, straight down it goes. But then you look up at night, and there's the moon, just kind of hanging out, circling us forever. So are these two things playing by different rules, or is there some kind of hidden connection between them? To answer that, we've got to go way back to the 17th century, to a moment of pure genius from none other than Isaac Newton. You know, the story about him sitting under a tree? It's famous for a very good reason. It totally changed how we see the universe. I mean, just think about that question for a second. It's so simple, but so powerful. Newton saw that apple fall and wondered, what if that same pull, that exact same force, reaches all the way out into space and grabs the moon, too? What if the moon is also falling? He guessed that it was all the same force. That was a massive leap. Okay, but wait a second. If the moon is falling, why on earth doesn't it just crash into us? Well, the answer is all about understanding what an orbit really is, and lucky for us, a simple analogy makes it all click into place. Okay, so picture this. You tie a stone to a string and start whirling it around your head. That stone wants to fly off in a straight line, right? But the string keeps pulling it inward, back towards your hand. It's this constant inward tug that forces the stone to keep moving in a circle. And that inward pulling force? It's got a name, centripetal force. It literally means center-seeking. In our little example, the string is providing that force. Now think about the moon and the Earth. What's the invisible string in that case? You got it, it's gravity. So here's the big aha moment. The moon is constantly falling toward Earth, just like the apple. But, and this is the key, it's also moving sideways incredibly fast. It's in this perfect balance of falling down and moving sideways that it ends up constantly missing the Earth, tracing that perfect orbit around us. And just like the slide says, if you could magically snip that gravitational string, whoosh, the moon would fly off in a straight line into space. This amazing insight led Newton to come up with one of the most important rules in all of science, a single law that could predict the movement of everything from apples to entire galaxies. There it is. Now, I know it sounds a little dense, but trust me, the idea behind it is actually beautiful and simple. It just means that everything with mass, you, me, this planet, the sun, is pulling on everything else. Let's break down the two key parts. First up, mass. The more stuff an object has, the more massive it is, the stronger its gravitational pull. It's pretty intuitive, right? That's why we're all stuck to the Earth and not gently floating toward our coffee mugs. The Earth's mass is just so huge, it wins every time. Second part, distance. Gravity gets weaker the farther apart things are. But here's the cool part. It gets weaker fast. It follows what's called an inverse square law. All that means is if you double your distance from something, the force of gravity doesn't get cut in half. It becomes 4 times weaker. It drops off really, really quickly. And here's the whole idea in one tidy little equation. The force, F, equals the two masses, m and m, multiplied together, then divided by the square of the distance, d squared. That g is just the special sauce, a number that makes all the units work out. But you can see it right there. Bigger mass, bigger force. Bigger distance, way, way smaller force. This simple formula is the rule book for the cosmic dance. Now, this law brings up something that trips people up all the time. We use the words mass and weight like they're the same thing, but in physics, they're totally different. Let's clear this up. Mass is how much stuff you're made of. Your mass is the same whether you're here on Earth, on the moon, or floating in deep space. It's a fundamental part of you. Weight, though, that's just the force of gravity pulling on your mass. And since gravity changes from place to place, so does your weight. So what does that mean for you? Well, the moon is a lot smaller and has way less mass than Earth, so its gravity is much weaker. If you could stand on the moon, you would only weigh about 1/6 of what you weigh right now. You'd still be the same you, the same mass, but you'd feel incredibly light. You could jump like a superhero. So the force of gravity, your weight, has some other really interesting effects right here on Earth. Let's look at a big one, the relationship between force and pressure. Let's go back to that simple example. Imagine you're standing on some loose sand. Your entire body weight is pushing down on the sand, but it's all concentrated on the small area of your feet. That creates a lot of pressure and you sink in. But now, what happens if you lie down on that same sand? The force is exactly the same. It's still your weight. But now, that force is spread out over the much larger area of your whole back. The pressure is much, much lower, so you don't sink. And that's the whole concept right there. Pressure is just how concentrated a force is. You can have the same exact force, but get totally different results depending on the area you spread it over. And we use this idea everywhere. Think about it. A sharp knife cuts because its edge has a tiny area, creating immense pressure. A nail has a sharp point to concentrate the force of a hammer and pierce wood. And on the flip side, huge skyscrapers have wide foundations to spread their incredible weight out, reducing the pressure on the ground so they stay put. So let's zoom back out and just appreciate what Newton did. It's incredible. He showed that one single elegant law could explain so much. The force that keeps our feet on the ground is the same force that swings the moon around the Earth, the same one that keeps the planets orbiting the sun, and even the same one that causes the ocean tides to rise and fall. It's all connected. But here's a final thought to leave you with. Newton's law is amazing at describing how gravity works. It lets us predict things with incredible accuracy. But it doesn't tell us why. Why does mass attract other mass in the first place? What is gravity? Answering that question, well, that would take another couple hundred years and another genius named Albert Einstein to reveal an even deeper and stranger secret about the universe.